Okay, in this lesson, we're going to talk about systems and solving them using the substitution method. So, recall that there are three main methods to solving a system, and that is graphing, substitution, and the elimination method. Substitution and the elimination method are the algebraic methods of solving. We're going to focus on the substitution method for this lesson. Remember that the solution to a system is the point of intersection. You can see right here, our point of intersection is 3, comma 2. So remember a point on the coordinate plane has two values, an x coordinate and a y coordinate. The idea of using the algebraic method of substitution is we're going to replace one of the variables in either of the equation with an expression. The process will produce an equation where we only have one type of variable. We will either have all x's or all y's in the equation. Therefore, this will allow us to be able to solve for that specific variable. So you can see here we have two equations. This is our system. So one of our equations, we have x equals negative 4y minus 18, and the other equation is negative 6y plus 5x equals negative 12. Now, again, the whole idea is to take part of the expression of one equation and substitute it in for a variable in the other equation. So here we have x equals negative 4y minus 18. So if this is what x equals, then we can substitute this expression in for the x variable in the other equation. So we're going to rewrite, and we have negative 6y plus 5. And instead of x, we're going to put what x equals from the other equation. So I'm substituting negative 4y minus 18 for the x. Now, take a look at this equation. We only have y variables, and then we can simplify this and solve for the y. So the whole idea is we want one type of variable, either all y's or all x's, in one of the equations, and then we can solve. So let's just go ahead and finish this out. We're going to distribute the 5. And then we're going to combine like terms. And we are solving for the y variable. And keep in mind, remember, a point on the coordinate plane has two values that make up the coordinate. And then we will divide. So the y coordinate of the point of intersection is negative 3. So when we write our ordered pair, remember to put the coordinate value in the correct spot. So it's x comma y. Now we know what the y is. To get the x value, we can go back up here to our first equation and we can replace or substitute what y equals. Negative 4 times negative 3 is 12 minus 18. Therefore, the x coordinate is negative 6. So -6, -3 will be our point of intersection. And just to refresh our memory, this is going to be in quadrant 3. So quadrant 1 starts in all the positive, and then it goes counterclockwise. Quadrant 2, 3, and then we have quadrant 4. So the point of intersection is in quadrant 3. So just like when we graph to find our solution, one requirement is that our equations have to be in slope-intercept form. There's also a requirement for substitution, like we just saw. The requirement to use substitution is that one of the variables, either the x or the y, in one of the equations must be isolated. So let's take a look at 5 equations and determine which equations has an isolated variable. Well, this first one has an isolated variable of y equals. Our second one has an isolated variable of x equals. Our third one does not have an isolated variable. Our fourth one does not have an isolated, it's almost. And then the last one does not have an isolated variable, but almost. So isolated means it has just a single variable with a understood coefficient of 1. Now, these 3 that does not give us an isolated variable, we could manipulate an isolated variable. But this is what you're looking for before you start using the substitution method. So again, we're always going to ask, is there an isolated variable? If not, we'll have to do some manipulation before we can start using substitution. So here we have a system, and we do have an isolated variable, and actually we have both equations has y isolated. So we'll just use our first y equals 4x minus 17. So y equals, so this is what y equals. So I'm going to take this expression that is y equals 4x minus 17, and I'm going to substitute it in for the variable y in the other equation. So instead of y here, I'm going to put what y equals, and we have 4x minus 17 equals negative 2x plus 13. And now we have only x variables. So we're going to solve for x. And then when we finish, remember we have to then get the value for y. So we're always looking for 2 values for our solution to our system. When we have variables on the left and the right, I always want to address the variable terms first. And for me, I like to address the smaller variable terms. So negative 2x is smaller, so I'm going to add 2x. Again, I always like to address the variables and not the constants first. And then we're going to isolate our x. And we get 6x is equal to 30. Let's divide by 6. And our x coordinate is 5. So x comma y. Now I can take this variable of x equals 5 and plug it into either equation to get the y. It does not matter. You will get the same answer in either one. So our y is 20 minus 17. Therefore, our y is 3. So this is going to intersect in quadrant 1. 5, 3 will make both this equation and this equation true. If I were to plug in 5 for the x's and 3 for the y's and work it out, I would get 2 true statements. Okay, here's our second system. Do we have an isolated variable? And we do. We actually have an isolated variable of x in both equations. So I'm just going to start out and use my first equation and say that x equals negative 6y plus 23. So I'm going to take this expression and substitute it in for the x variable into the second equation. I have all y's, one type of variable. Variables on both sides, I'm going to address the variable terms first, and negative 6y is the smaller one, so we're going to add 6y to both sides. Isolating y, we're going to add 12. And dividing by 7. Our y value is 5. So again, make sure we put it in the right spot of our coordinate. Now I'm going to take that y equals 5 and plug it into either of the equations. I'm going to plug it into the second equation. So x equals y, which is 5 minus 12. X equals negative 7. So negative 7 comma 5 is our point of intersection. This is going to be in quadrant 2, so negative positive. So our two lines are going to intersect in quadrant 2. Okay, do we have an isolated variable? We do. So we have y equals negative 3x plus 1. I'm going to substitute it into the other equation. Instead of y, I'm going to have negative 3x plus 1 because that's what y equals. I have variables on both sides, so I'm going to address the smaller variable first, which is negative 5x. So we're going to add 5x to both sides. We get 2x plus 1 equals 3. Isolating our x, and the x value is 1. Again, putting in the right placeholder. I'm just going to plug it in to the first equation. When I say it, I mean the x value of 1. We're going to multiply and then add, and we get negative 2. So 1 comma negative 2 is going to be in quadrant 4, positive negative. So the point of intersection is in quadrant 4. Do we have an isolated variable in this system? We do. So this one's going to look a little different, but the process is the same. We have an isolated variable of x. X equals y plus 11. So I'm going to replace x with y plus 11. So we have to use parentheses. So it's 2 times x. X is y plus 11 minus y equals 18. So this time our y's are on one side, so I'm going to distribute and combine like terms and subtract out 22. And our y value is going to be negative 4. So I'm just going to take that and replace y with negative 4. And our x value is going to be 7. So the two lines intersect in quadrant, so that would be positive, negative in quadrant 4. So this ordered pair will make both this equation and this equation true if we were to plug them in. Here's our next system. We do have an isolated variable. This time we have y equals negative 2x plus 8. So we're going to substitute and replace the y with negative 2x plus 8. Again, we will need to use parentheses. Distribute the 3, we get negative 6x plus 24 equals 6. We're going to combine like terms. So 6x minus 6x is 0, so we simply have 24 equals 6. Now, recall that whenever you are solving an equation and your variables are eliminated and you're left with a false statement, this means there is no solution. So this means these two lines were parallel and they would never intersect. If we were to rewrite this equation in slope-intercept form, we would see that they would have the exact same slopes in different y-intercepts. So these two lines will never intersect, so there's no solution. Here, do we have an isolated variable? We sure do. So y equals, I always like to circle my expression that I'm substituting in. And I'm going to replace y and substitute in 6x plus 22 equals 4x plus 14. Variables are on both sides, so we're going to address the smaller variable, and I'm going to subtract out 4x on both sides. We get 2x plus 22 equals 14. Subtract out the 22. 2x equals negative 8. Divide by 2. And the x-coordinate is negative 4. So negative 4 comma something. I'm just going to replace y equals 6. X is negative 4 plus 22. Y equals negative 24 plus 22. Y is negative 2. So this time our point of intersection is in quadrant 3. So this is where the two lines will intersect. This is our one solution, negative 4, comma, negative 2. Do we have an isolated variable? We sure do. Y equals negative 6x plus 20. Let's substitute that in for the y variable. In the other equation, we're going to use parentheses, so minus 3. Instead of y, we're going to write negative 6x plus 20 equals negative 6. Now we have to distribute. So a negative times a negative is positive. And then we get negative 60 equals negative. I think underneath here is a 0. I think this is supposed to be negative 60. So let's make it like that. I'm almost positive that is. Because when we combine these terms, we get 0x. And this time, we have no variables, but we have a true statement. Negative 60 does equal negative 60. So this time, when our variables were eliminated altogether and we get a true statement, this means there is infinite solutions. This means these two lines, if we were to convert this second one into slope-intercept form, it would look just like our first one. They are the same line. So we use the word coincide. That means each point of this equation coincides or lies along the same points as our second equation. They coincide with one another. Infinite solutions, same exact line. Okay, now we can finally answer the question, is there an isolated variable? And the answer is no. So we can still use substitution, but we're going to have to isolate one of the variables in one of the equations. So what I look for is the least amount of steps to isolate a variable. So I'm looking for a variable that has a coefficient of positive 1. Now you can see in the first equation, this y has a coefficient of negative 1. And in the second equation, we can see that x has a coefficient of positive 1. So we could isolate x with one simple step of subtracting 3y from both sides. So that's what I look for. But there are infinite amount of ways to solve a system using substitution. So I am going to first isolate x, and then I always like to put my variable term first. So now when we ask the question, is there an isolated variable? We can say yes, x is isolated. So I'm going to take this, what x equals, and substitute it in for the x in the first equation. So -7, instead of x, we're going to substitute -3y minus 7 minus y equals 9. Now let's distribute the -7. We get positive 21y plus 49 minus 1y equals 9. Now let's combine like terms. And when we combine that, we get 20y plus 49 equals 9. We're going to isolate y by subtracting 49. We get 20y is equal to -40. Divide each side by 20. And our y coordinate is -2. Again, make sure you put it in the right spot, x comma y. Now I'm just going to come up here into this equation and substitute in -2 for y to get the x coordinate. So a negative times negative is positive, and our x coordinate is -1. So these two lines, the system intersects in quadrant 3. Our solution is -1, -2. Here we have another system, and the answer to our question, is there an isolated variable, is no. So I'm going to check to see which of these variables has a coefficient of +1, and it looks like this x. So I'm going to isolate this x simply by adding 2y to both sides. X equals 2y minus 15. Now I have an isolated variable. X equals 2y minus 15. I want to substitute this expression in for this x. So 2 times 2y minus 15 plus 5y equals 15. We're going to distribute, and then we are going to combine like terms. So when we combine 4y and 5y, we get 9y minus 30 equals 15. We're going to add 30 to both sides. We're going to divide by 9. And our y coordinate is 5. Now I'm going to come up here, and I'm going to replace this y with 5 to get the x coordinate. So we just always have to remember, once we find one value of our solution, we have to plug that value back into any of the equations. But we're always looking for two values to create our one solution point. So this is going to be in quadrant 2. Our two lines intersect in quadrant 2 at -5, 5. Okay, let's do one more. We do not have an isolated variable. I'm looking at all my variables in both equations. None of these have a +1 coefficient. So we can just decide, we can isolate this x, this y, or this y. It does not matter. I'm just going to go ahead and isolate x here. But again, you can do this many different ways, and you will still get the same answer. This time, I have one more step. I have to divide every term by -1. And so x is equal to negative y minus 3. So I have an isolated variable. X equals negative y minus 3. So I'm going to take in, substitute it in here. Parentheses, so x equals negative y minus 3 minus y equals negative 4. We're going to distribute the negative 8, so that gives us positive 8y plus 24 minus y equals negative 4. We're going to combine like terms, so 8y minus 1y is 7y plus 24 equals negative 4. Subtract 24 from both sides and divide by 7. And our y coordinate is negative 4. I'm going to take and just plug that right here. X equals negative. So be sure that you include the negative. I'm going to use a parenthesis. Y equals negative 4. So this is where you have to be super careful when you have several negatives going on. Negative 1 times negative 4 is positive 4. And 4 minus 3 is 1. So our point of intersection intersects in quadrant 4. So this is the solution to this system. And I hope this helps.